Welcome to this class on pre-programmed reactions part 2. We have seen what are pre-programmed reactions in the previous class. In this class we will discuss what are the features of pre-programmed reactions. Perturbations to vertical posture are corrected through pre-programmed reactions, and how corrective stumbling reactions can be considered to be a form of pre-programmed reactions. Okay. Importantly, note that pre-programmed reactions depend significantly on instruction to the subject or the intention of the subjects. The subject is told to not respond, do not intervene. Actually, it is not clear what this means. If you cause a perturbation and tell the subject do not worry, do not intervene, it is difficult for them to not do something. This is like the example of a classroom in which you tell the students to not do something, or do not think about the monkey. Everybody immediately thinks about the monkey. So, it is difficult to not do something. So, there are several ways in which you can ensure that people do not focus on that, on what you do not want them to do. By the way, also it is not clear whether the subjects have followed your instruction. You want them to not respond to a perturbation. How can you be sure that they did not respond to that perturbation? Actually, there is a way of doing that. If the response to the perturbation is caused by say 2 or 3 or 5 muscles, for example, the response can be caused by 5 muscles, you can measure EMG of those 5 muscles in sync with the perturbation. So, when the perturbation happens, just some few hundred milliseconds just before the perturbation, there will be a baseline EMG activity. By the way, that is never going to be 0, there is going to be a baseline EMG activity. If after the perturbation also the same baseline activity continues for the next couple of 100 milliseconds after the perturbation, then the person is not reacting. If the baseline activity has shifted to a higher level, then the person is reacting. If you ask them, did you follow my instruction, they will tell you, yeah, I followed the instruction. Whether they are telling the truth or not is something that we can find out by the EMG. Okay. So, that is one way in which you can ensure that So, in particular, it is important in the case of pre-programmed reactions, if you tell the subject to do not intervene, they can reduce the amplitude of the response, or sometimes the response completely disappears, there is no response, that also is possible. So, there is a strong dependence on instruction or context. So, that means there must be, we would immediately believe, we would immediately hypothesize there must be cortical involvement in this, okay, because there is thinking. So, by the way, that does not mean that the execution needs to involve cortical involvement, that is different. And also not just that, there is a activity that can happen not just during shortening, but also during lengthening, but also in cases where the length does not change. And also we said earlier that there is a poor correlation, the amplitude of the stimulus and the amplitude of the response. Okay. One thing that we have seen in the previous class is that if the perturbation is applied in the presence of vibrations, high frequency vibrations like that, so on and so forth. If the perturbation is applied in the presence of vibrations, what we have seen in the previous class is that in the presence of vibration, the H reflex or the T reflex amplitude goes down, the monosynaptic reflexes are suppressed by vibrations, but the M23 reactions are not suppressed by the vibrations. So, vibrations have an influence on the monosynaptic reflex, but not on the pre-programmed reactions. Okay. So, also what happens during corrections of vertical posture. So, remember, one thing to note is that human posture, bipedal locomotion, bipedal stance is relatively unique, very special case, and there is a reason for us to hypothesize that this posture is always in a pre-programmed state, or perturbations to this posture. When somebody is pushing me, there is going to be a response that is going to arrive at latency similar to pre-programmed reactions, because we do not want to fall. it would be reasonable for us to expect that unexpected perturbations of the vertical posture will lead to responses similar to pre-programmed reactions. Okay. So, what that means is that they will occur at latencies that is between the phasic stretch reflex or M1 and the voluntary reactions, just 200 milliseconds between that. So, or in other words, it will happen at around 80 milliseconds, 70 to 100 milliseconds. Importantly, it is worth noting that the response in the case of reflexes is going to be muscle specific, whereas in the case of pre-programmed reactions, they are specific to the mechanical action. So, if the mechanical effect of the perturbation is to make me fall down in the, say, on that side, then the response is going to bring me back to that side, the response is going to be in that direction. Whereas, if the mechanical action of the perturbation is pushing me in that direction, then the response is going to bring me back in this direction. So, the response is not muscle specific, but rather specific to the mechanical effects of the perturbation, okay, and also not necessarily to the exact point of application. The perturbation may be applied to any point or to any muscle. If the mechanical effect is such that it is going to cause perturbation in or fall or some disturbance in a particular direction, the response is going to be in the opposite direction, which is why we call this as functional stretch reflex, is it not? It is functional. So, depending, it is not a crude, it is relatively crude when compared with a voluntary response, but it is not a crude response that has no sensitivity to what is the direction of the mechanical perturbation. It is not like that. So, depending on the direction of the perturbation or the mechanical effect, the response will be in the opposite direction regardless of where the perturbation is applied. Okay. And this can happen independently of the afferent source. So, it need not be, which we said this earlier, that that this can happen depending on whether the afferent source is visual, auditory, vestibular, etc., etc. An example is the case of having a hot liquid in a moving platform. Now, these are great experiments, someone should do these experiments. So, suppose I am having a hot liquid in this, or let us just say that this is empty. Okay. Let us just say that this cup is empty. Okay. Now, I am standing on a moving platform, somebody is just moving me, and or in other words a wheeled platform like this, right, that as it has been shown here, so wheeled platform. Now, if people are pushing me, my response is going to be something, right, when the cup is empty. Let us say that it is filled with a lot of play dough, okay, or clay that is used for playing, kids use this, right, I am filling it with that and I am having it in my hand. Let us say its mass is 200 grams for example, or 300 grams, whatever, some number, somebody is pushing me, the response is going to be something, we record this response. Okay. Let us suppose the initial condition of all these experiments are the same, all these trials. Actually, that is very difficult to ensure, because you cannot be sure that the initial conditions are always the same, there is no such thing like that, but let us assume that is true. Okay. And in the third case, I am having a hot liquid, I am having coffee, very hot, piping hot coffee in this, right, or something like that, and it is full, and now somebody is pushing me, the reaction will be something. Now, if I compare the three reactions, right, the empty cup versus the cup filled with Play-Doh and the cup filled with coffee, the response will functionally change depending on whether I have the hot liquid or not. In the first two cases, me not falling down is an important consideration, that is my intention. My intention is I am not really worried about this going down like that or Play-Doh falling down, because that is less of a concern. I should not fall down, that is my aim in the first two cases. In the third case though, somehow it is possible that it is important for me to not spill the hot liquid on my body, because it could be a source of embarrassment, but more importantly it could be dangerous, it could scald my body, it could cause injury to my body. I do not want that to happen. So, then the response will vary significantly, not slightly. So, in other words, the intention plays an important role, and there is definitely a great amount of context specificity in that case. Okay. And so, there are these corrections of vertical posture which are almost always in a pre-programmed state, and any corrections to the vertical posture that happen at around that latency, 80 millisecond latency, can be considered to be a pre-programmed reaction. Okay. Now, in the case of locomotion, for example, we keep walking, we take step by step, right. If we are taking one step, that can, and by the way, let us remember one thing, as we are making a movement, let us say that I am standing and I am making a fast arm movement, right. Before we go to the next topic, suppose I am standing and I am making a fast arm movement, or I am holding an object that I am dropping, I am holding a heavy object, 10 kg object that I am dropping, right. If I am doing that, let us remember that the perturbation is caused by my own actions. I have done something that perturbs my equilibrium, that has affected my equilibrium. Even in that case, the response will be there, that could be pre-programmed reaction. So, in other words, the response or the perturbation can be triggered by an external source or by the subject himself. So, that means even in cases where there is a perturbation that is caused by the subject's own movements, there is going to be a response. By the way, so that means that when I am, so this we do all the time, we walk and we do something else. While we are walking, there is that which by itself is a movement, and we are like, by the way, a frequent thing that we do is seeing the phone, but we also do many other things while walking. So, while walking, so the other it is possible that walking serves as a perturbation for the other activity that you are doing, or the other activity serves as a perturbation for the walking that you are doing. So, it is possible that could happen. Okay. So, during locomotion, it is important to have stability, sufficient amount of stability. So, this is also another activity in which there is sufficient pre-programmed response that is available. So, what happens is that when a person is walking and you see there is a small obstacle, sudden obstacle that comes, the response changes as a function of when the stimulus is detected or in which stage of walking the stimulus is detected. This is classical experiments with cats, and so let us assume that this is a cat whose this is the cat's paw, this is the cat's upper leg and lower leg, and this is the paw, right. Now, if a stimulus is applied, what is the stimulus? This could be a painful stimulus, quite literally a nail, but it can be even an air puff, right. Suppose an air puff is started when the cat's leg is in the air during the swing phase. If during the swing phase the cat detects the presence of an air puff here or detects some painful stimulus, then what the cat will do is it will step over the obstacle and come put the leg here. Usually the leg would have come here, later because of the obstacle the leg would come here. Why is this happening? Because the perturbation is detected here, I do not want to keep my leg on the obstacle or on the painful stimulus, I want to avoid that. So, the leg is kept on moved at that. But if the stimulus is applied during the stance phase, so in this case what is happening, the foot or the paw is on the ground. So, this is the stance phase, is it not? If the stimulus, if the air puff is applied at the time of stance phase, what it does is immediately it withdraws and takes the leg up. So, in one case it brings the leg forward and down, and in the other case it takes the leg up and flexes. So, that means the response is context specific. In both cases, remember, in both cases the stimulus is applied at the same point in the body here, and in both cases the amplitude of the stimulus is the same, which is an air puff, right. Depending on what the context is, whether you are in the swing phase or whether you are in the stance phase, the response changes. Okay. So, such responses, we also do this all the time, even in humans. If there is an obstacle, depending on when you are detecting the obstacle, the response will vary. Such corrections during gait are called as corrective stumbling reactions. These typically happen at latency similar to pre-programmed reactions. So, these can be considered to be a form of pre-programmed reactions. Okay. Another classical example before we end the class is, let us say that there is a sleepy classroom, and the teacher is asking the students, say, okay, all of you are sleepy, let us do some exercise, stand up, down, up, down, up, down, up, down, and then he says up, up, right. When they do that, when an up is followed by another up, people will sit down if they are used to sitting down, up, sitting down and standing up. If they are doing this in a cycle, and suddenly when the teacher is saying up, up, right, you will see that many students will actually sit down for the second. This is another example of pre-programmed reactions. So, in this case, let us remember that it is not the specificity of the stimulus, or you are just hearing some noise, you are not checking whether that is up or down, immediately the person is sitting. The presence or absence or the trigger alone works. Okay. So, that is another example of pre-programmed reactions. So, we have in this class, so what we have seen are the features of the pre-programmed reactions, or in other words, strongly dependent on instruction, and the subject can pre-program any function, and perturbation amplitude does not correlate well with the response amplitude, and vibrations can cause suppression of the T reflexes or M1 or phasic stretch reflex, but does not cause suppression of the pre-programmed reactions. So, these are the features, and there are corrections of vertical posture that are specific to the mechanical effects of the perturbation, okay, and corrective stumbling reactions. So, whether you are stepping over an obstacle or whether you are removing the leg from the obstacle depends on the context, depends on when the perturbation is detected, right, and all these things happen at latencies typical of pre-programmed reactions that can be considered to, so they can be considered to be pre-programmed reactions. Okay. So, with this we come to the end of this class on pre-programmed reactions. In future classes we will be focusing on more voluntary or brain controlled movements. Okay. So, thank you very much.